Hello YouTube, my name's Graham and this is the first work in progress of my Arduino powered 18650 multi-discharger. Now this project borrows very heavily from Adam Welch's work and extends it a little bit further by adding in the multi-cell functionality, and the way I've done that is by sort of basically rewriting the software a bit to include a menu system that allows me to scroll through 4 cells with an Arduino Nano, 3 cells with an Uno, and potentially 8 cells with a Mega, just due to the number of analog pins that can be used to sense the various voltages, cell voltages and shunt voltages. So what I've done is implement some switches which I borrowed from Jeremy Blum's site, and I've basically got 2 switches, one which allows me to select which cell I'm looking at, and the second switch which allows me to change the status of the cell. So when we look at the LCD menu that I've got here, so you can see at the moment I'm looking at cell 1. If I press the switch, it jumps to cell 2, to cell 3, and to cell 4, and then press it again and it cycles back to cell 1. So at the moment I've only got 1 cell plugged in. I've also got no resistors at the moment, so the voltages that it's showing for the actual 18650 is correct, but I'm simulating the shunt voltage by using 2 AA batteries which are putting out about 2.5 volts, so I'm treating that voltage as my simulated shunt voltage, which allows me to do the calculations for milliamp hours and things. So I'm just going to reset this so you can see my lovely splash screen. And so yeah, we're looking at cell 1, and this cell is by default they go straight into a waiting state, so that they're all ready to go. If I just explain what we've got, then so we've got over here, we can see which cell we're looking at, the voltage of that cell, and when it's discharging you'll be able to see the amperage and the milliamp hours that are generated. Oops, lost focus there, sorry about that. Yeah, so and then there's the status of this particular cell, the elapsed time of the discharge, and then at the bottom this 1, 2, 3, 4. We'll say at the moment because I'm using a Nano, it's set up for 4 cells, and those characters underneath sort of denote the state of each of those 4 cells. So they're all 4 are waiting, and the other states are discharged and finished, discharging and finished. So if I effectively start this cell discharging, it's simulated discharge. You see it immediately changes to discharging, and the little D under the 1, and you can see that it's simulating a discharge of 1.45 amps, and the milliamp hours are creeping up. Now, as per Adam Welch's program, I've got it so that it should cut off automatically once the cell voltage drops below 3 volts, but obviously that's not going to happen with this test environment. But I also thought that you might want to part way through a discharge cycle stop for some reason. So you can, by pressing the second switch, change it to finished, and you can see, oh, I've got some weird numbers there. Yeah, I'm still debugging a little bit, but I can still scroll through the cells, and it tells me, you know, that the state is now finished. There's an F underneath the 1. We were discharging for 43 seconds. During that time, we had a peak of 1.45 amps and 16 milliamp hours. So yes, I think the interface is pretty much there now. So I can, if I start one of these ones that isn't connected at the moment, you can see at the moment I've got some extraneous voltage showing. And I think that is just because the pins are floating and not tied to ground or tied to anything at the moment. So it's giving me some weird figures. So if I try and do it on one of these ones, it tries to showing is discharging, but there's obviously nothing there, so I can stop it and yeah, cycle through my menu system. So this was using the sort of the two hardware interrupts on the Nano for the switching, and they just run sort of a couple of little interrupt scripts that change the cell that you're looking at. So yeah, it stores all 4 cells until you press set the cell status back to waiting again. So the next thing is to actually tie it into some proper resistive loads and add in the MOSFETs. That's the next stage as well, and yeah, see if it all works together, and then maybe do it on some perf board or something like that, and see if we can get a bit of a neater solution. Yeah, there we go. That's where I am at the moment. Thank you very much.